partial variation for the grade 9 applied level course. The goal for today, before we move on, is for you to be able to tell the difference between direct and partial variation, which of course means knowing what partial variation is, and we're going to solve problems using what we call fixed and variable cost, and you'll understand that pretty well by the end of this video. So Charlie, of course, is concerned about partial variation. He doesn't like it very much. It means more math. And look how concerned he is. Moving on. Okay, what I've got here then are, and you've got it in front of you, so I'm going to make this smaller. You can start copying. We've got two pictures. The first picture on the left is what I call direct variation, or not me, everyone in the math world calls this direct variation, and this partial variation. And they look fairly close, so the main points to see, you know, it's a straight line. Well, so is partial. Okay? Here's the big thing. Direct variation passes through 0, 0. Partial variation does not. Okay? The vertical intercept is 0, and that means, what that means is, you know, the point that it crosses the y-axis. Remember, this is the y-axis. This is the x-axis. And where it crosses this axis is at 0. That's called the vertical intercept. Here, y and x, you can see that it crosses at something other than 0. In this case, it looks like, I don't know, 25 or something. Okay? But the vertical intercept, which is, you know, where it crosses this axis, is not 0. And that's what partial variation is. So actually, you're going to pause the video. I'm not going to stop videoing, but I want you to just pause and do these questions. Which of these represent partial variation based on what I just told you? Okay? And there is a question at the bottom too, question number 2, which is identify the vertical intercept. Straight line passes through 0, 0 is direct. Straight line does not pass through 0, 0 is partial. Okay, so if you joined in with me again after doing those questions, now we talk about fixed and variable cost. So here we got a pizza, and the basic price, if you just bought it with just nothing else on it but the sauce and cheese, is going to cost $9. Doesn't matter what, you always have to pay that $9. And then after that, if you want any toppings like pepperoni, green peppers, whatever, then you pay 75 cents for every topping. Okay? And so this idea of what's fixed cost? Well, the fixed cost is the $9. No matter what, you got to pay that $9, right? That's fixed. The variable is this, the 75 cents for topping. Okay? So variable, and you notice how we write 75 cents as a decimal of a dollar. It's a rate. In fact, it would be our rate of change. Okay? No, per rate. Whoops, don't write that. It's per topping. That's the variable cost. So no matter what, you, me, and everybody in the whole world who goes to this pizza place is going to pay $9. Then all the end cost of our pizza will change depending on how many toppings we ordered, right? Topping. Boy, I would never pass the Lucy test. All right. Here we go. Moving on. So just in general, the idea of fixed and variable cost. The fixed cost is something you pay and that doesn't change. Everybody pays that. Okay? And it turns out the fixed cost, this is relevant and important, the fixed cost is the vertical intercept on the graph, reminding you that the vertical intercept, if I have, you know, my grid here, the vertical intercept is where it crosses right here. Okay? So that point is the fixed cost. The variable is the part that depends, in this case, the number of items, the items of pizza. And variable cost is the rate of change. So if we calculated the rise and run here, we would have the variable cost. If I'm going too fast, you go ahead and pause, but I'm going to move on to the next one. I want you to have this completely filled in though. Okay, so fill in the table below for the cost of a pizza with anything between 0 and 8 toppings. So now you just figure out, use a different color so we can see it better. And we can just use our calculator or our brain for this. So If we buy a pizza and it has 0 toppings besides the sauce and cheese, it's $9, right? Every time you add a topping, you add 75 cents, right? So $9.75, you have 1 topping, $10.50, so it's just 75 cents more for every extra topping. So this tells me then, I want to go buy myself a pizza, I can just look at this chart to tell me at Ferd's Pizza Parlor or whatever, you know, an 8-item pizza is going to cost me $15. I would never take 8 items. I don't like that many different things. I would probably choose 2 or 3 items, but anyway. Okay, so the question then is to draw a graph for the cost of pizza depending on the number of toppings. So the cost definitely is dependent. So independent is going to be the number of toppings. Okay, it doesn't really, that only depends on the purchaser's interest. And the dependent variable is cost, because as it usually is, because it depends on the number of toppings you get, right? And you see I chose my grid, I chose my x-axis to sort of match my table of values, and my y to match my table of values as well, so it'll be nice and easy. Okay, so please don't write this yet till we get the, let's get the graph drawn. So 0 top, I'm going to draw this little, I forgot to do this earlier. You know, when you do the zigzag, that just says I'm jumping from 0 to 9, and then after that it goes up by just increments of 75 cents. Okay, so 0 toppings, maybe I'll do this in a different color. 0 toppings is $9 right here. Looks like that's my vertical intercept. 1 topping's $9.75. You know, I chose it to work, so it's nice. But it is important that you go up by regular increments on the y and regular increments on the x. Otherwise, you don't really have a proper graph. You're kind of faking your data. Okay. So I drew my graph. I can now add my line. Oh, here's another one. Dashed or not. I wrote it here. The line has to be dashed because I can't get, 1.5 toppings, right? You can only have, or 1.2 toppings or something. It has to be a multiple, right? It has to be. So I have to draw it with a dash line because the in-between points, don't really count. Okay. So there's my line. Notice my points aren't perfect, and that's okay. It's just hard to get it absolutely perfect. Okay, so just looking at the information that you may or may not have copied yet, determine is it partial or direct? Well, it's partial because there's a base price, and it starts here. It's not starting at 0, 0, it's starting here. The vertical intercept, again, that's this point where it crosses the line crosses the y-axis, and dashed because, like I said. So it says find the rate of change. So the rate of change, again, is rise over run, always. And you can use any part of the graph to find that. As long as it's a straight line, you can use any part you want. So I'm going to choose this point and this point. Now I'm not using 0 this time. So my run, so I go from here to here on my run, and from here to here on my rise. So I'm just making a triangle. So my rise goes from 9 in that point to 10.50. And my run is from here to 0. That's 0. So my run is 2. So my rise Whoops. Oops, oops, oops. That was really, really dumb. My rise was not 1050. It's 1050 subtract 9. Right? It's how much it's changed from here to here. So that's going to be $1.50. Right? Because it starts at 9, goes all the way up to 1050 in that time frame. So that's 150. That was really dumb. And my run is 2. And that works out to 0.75, which we knew that, $0.75 per topping. Okay. Don't forget I made that dumb mistake right there. That's a big deal. Your rise is not what the y value is, it's the difference. It's how much it's changed in the period that you're measuring between your 2 points. There's my 1 point, there's my second point. It's a change in y. Okay. Next. Oh, write an equation to represent the cost of the pizza, and this is really important. So, for a partial variation relationship, what you have is this. You've got the cost, we should say let C be the cost, and we'll let, how about a cursive T be the number of toppings? So my cost is equal to, let's look back at the graph. No matter what, it costs $9. Doesn't matter what you do, so it has to be $9 plus something. And it's $9 plus 75 cents for every topping, right? And that was the initial thing they told us at the very beginning, right? Let's go back to the very first. It says, the cost of pizza is 9 plus the 75 cents for each topping. So if T is the number of toppings, then the cost is going to be the $9 no matter what, plus 75 cents, or we say it in dollars, times the number of toppings. And that's my equation. That's my equation for my pizza. Okay? And this is what a partial variation relationship equation always looks like. There's always some number that represents the y-intercept plus the rate of change plus times the number of toppings. So the form is y equals, you still have the, you have some number, and we'll call that number, I don't know, C, plus kx. So k is rate of change, and I shouldn't have chose C. Take it back. Take it back. I don't want you to confuse it with cost. Y equals, we'll call it B. B plus. Sorry if I made you erase. So that'll be your vertical intercept. Or you could say it's my fixed cost plus my variable cost plus times x, whatever. Anyway, so pause the video here. I'm actually going to stop and I'll make a new video for our last example.